this third and final day of this exclusive certification program, which we are doing through IPM and on condition-based maintenance. And as we all know, this program we are doing in association with CIOs of India, NASSCOM COE, and CIOs of India. So far, in the initial two sessions, we have covered fundamentals of condition-based maintenance by Professor Barik and its relative benefits over breakdown maintenance or traditional period-based preventive maintenance. That's what we covered on the very first day. Yesterday, Professor Bishwajit covered fundamentals on vibration monitoring, the parameters of interest in vibration monitoring, types of sensors, its construct, and how sensors can be deployed to monitor triaxial data points. He also provided a brief on how to make sense of the frequency and amplitude linked to vibration data. And just to give you a quick recap, on the first and the second day, that is yesterday, we had leaders of Adani Wilmar and Deepak Fertilizers speak about their journey to modernize maintenance practices in their setups through usage of smart sensors and linked analytics, of course. Because unless you make sense out of these sensors, it's just another set of data. And so what emerged is that with these specifically and specially designed sensors installed on the machines, you are able to continuously monitor the health of equipment, and then you can draw a complete plant asset management system, so to say. Earlier, as Professor Bishwajit yesterday mentioned, these techniques and these tools were a very expensive proposition. But now, as we learn from Adani Wilmar in the last session and also from Deepak Fertilizers, these sensors have become very cost effective and can be adopted by manufacturing setups to achieve due reliability in their operations. So what we would do today is we will start with a couple of these case studies. But before we do so, I will request Annie Matthew, Vice President of CIOs of India, to welcome all of us present today. Over to you, Annie.
Good morning, everyone. Good morning on a bright Sunday morning. To see a great attendance and so much of enthusiasm for the concluding session of the vibration analysis, the condition-based maintenance module. I think it has been a fantastic 2 days where there has been a lot of learning. This is the concluding session. I think yesterday a few terms were bouncers to a lot of people. We were hearing fast Fourier transforms after a long time. I think it marks the migration of the journey of the CIO from IT to OT. I think that is where those boundaries which traditionally used to be between the manufacturing side and the IT side are over a period of time have been going down. And this helps, these kind of sessions help us get into understanding the more technical aspects of OT and how to interpret it and communicate with our manufacturing counterparts. As we go along, we have been conducting on behalf of CIOs of India, and the first session, this one on behalf of CXOs of India, we have been focusing on health, on networking, on sharing through our GAN Hub sessions, and leadership and mentoring too, right? We have a Paul Dupuis session on 11th of November to look forward to. As Kamal just showed in the PPT, we have a very exciting session by Sunita Narayan on 22nd November, where we will be marking Bala's anniversary through the Bala Memorial Lecture. So, and we will be having few GAN Hub sessions also as we go along. So a lot of exciting things to look forward to. Without any ado, let us continue with the session. Let us delve into technology aspects once again. Of great learning to everyone.
Thank you, Annie. And am I audible?
Yes, you are.
Great. So thank you, Annie, to basically indicate that these kind of sessions are important to demystify these terminologies which are used by business domain heads. And for us to have meaningful discussions with them, we need to have those understandings so that we can have a dialogue and not just keep taking notes from them. So good. It's a great thought, I would say. So before we begin, let me just give you a quick context that during the session yesterday and later as well, we got some questions on how CBM can be deployed in our existing plant setup. So one is you have a greenfield plant wherein you have everything afresh. You can buy equipments which with the latest technologies embedded. But in a brownfield setup, which is a plant which is already in existence, how do you deploy CBM and these new age technologies? So that is something which came out very clearly in yesterday's session and also on the very first day. And this being an important point to narrow down on practical usage of CBM, we will have a brief on 2-3 specific use cases which we can relate to easily on how companies have leveraged CBM in their plants to achieve more reliable operations and at lower overall cost, of course. For this, I will request Ronak to quickly give his practitioner's viewpoint. And for those who do not know Ronak, let me give you a brief introduction. Ronak, he is actually formally known as Dr. Ronak Bingay, and he is a PhD from the Department of Mechanical Engineering, University of California, Berkeley. He did his graduation and post-graduation in engineering from IIT Madras, and he has to his credits 4 international patents and 16 publications in the field of high-frequency predictive analytics and scalable machine digitization. He set up this company, Infinite Uptime, in 2015 in US. And as we speak, the company is rated as amongst the top 10 IoT companies in the APAC region by a leading rating agency. And he's a delegate to the University College of Dublin and more. I can go on and on, but I'll not let the so that people learn from you, Ronak. Over to you. Please take us through these case studies and make us more evolved in this journey.
Thank you so much, Atulji. Can you hear me clearly? Am I audible?
Very much, very clear, very clear. Go on.
Okay, thank you so much. So what I will do is, based on this request of case studies, I'll present case studies from multiple viewpoints. One from a plant perspective, like you said, a brownfield plant. One from an O&M perspective. So there are a lot of O&M companies who take up operations and maintenance of an entire plant, right? Typically for distilleries and things like that. And one from an OEM perspective. So what are OEMs who manufacture rotating equipment, who manufacture motors, fans? What are they doing as part of CBM? And this will help more from the greenfield perspective.
Yeah, go on.
So I'm just going to share my screen. Let me know once you can see my screen.
Yeah, we can see your screen now.
Okay, great. Thank you so much. So good morning to everyone, and happy to share with you a few case studies which will help understand how CBM that we've been learning over the last couple of days, couple of sessions in this workshop can actually be implemented, and what companies from different aspects, plants, O&M companies and OEMs, how are they implementing CBM in their perspective domains, and how it's benefiting them and how they are using this to derive value out of it. So I'll start with a brownfield project, a brownfield plant. So this is a case study that I'm talking about from the steel industry. So the problem that the steel industry was facing, a very specific problem at a cold rolling mill, was that there were several erratic bearing failures that were happening on multiple rotating equipment, right? As you are aware, in a steel cold rolling mill, there are a lot of rolling motors and rolling machine gearboxes, and these motors and gearboxes keep going under loading and unloading patterns as the steel rod goes through the cold rolling mill. And because of these loading and unloading patterns, which are quite different in nature, because you have different thicknesses of steel which is going through the cold rolling mill, it's not very easy to predict what's going to happen on these motors and gearboxes over a period of time, which causes a lot of premature bearing failure. So this was a problem that was being faced at this cold rolling mill. The impact was, of course, unexpected downtimes, and because of unexpected downtimes, the inability to deliver as per the dispatch target. So typically in the steel industry, you have certain targets in terms of what you're trying to produce in those mills and what you're trying to push into the next level of manufacturing. So that wasn't being achieved because of these downtimes. So the workaround what was being used, so of course, every problem has an immediate workaround that can be achieved. So the workaround being used by this company was that they hired an outsourced agency for the vibration monitoring. So vibration monitoring, as we all know, has been a 30 to 40-year-old science, right? And it has evolved over time, right since the day we found out that vibrations is a good indicator of a breakdown or of a fault. To today, what we are talking about in terms of fast Fourier transforms and using these kind of technologies to pinpoint what is the source of failure. So an outsourced agency was hired, right, which basically walks manually to every machine, checks the level of every machine once a month, and gives a report, based on what vibration levels are there, what based on what frequencies are seen, based on what diagnosis they conclude, from that data. They also increased the inventory of bearings by 2 times. So 2x was the inventory that shot up in this workaround. This was mainly because because the failures were so erratic in nature and unpredictable. It was important to have spares on hand so that the time to repair, the MTTR or the time to repair was as low as possible. So in that case, the number of bearings in the stock or in inventory had to be increased, right? So that was one more thing that was done. And the third thing was the overhauling interval was actually reduced, right? So typically preventive maintenance is a time-based maintenance practice. And, there is a kind of an optimization between the preventive maintenance schedule and the actual production planning and the production process. So what was done was actually the optimization was done on the intervals of preventive maintenance, so that overhauling, replacement of bearings, replacement of spares was actually done more often than was probably recommended by the OEM, so that they could prevent any such premature bearing failures. So of course, the workaround definitely helped, and it is supposed to help, right? So the workaround definitely helped, but of course it came at a very high cost, right? So there was increased maintenance costs. You had this additional outsourced agency which had to come and check the vibration of every machine. There were increased repair and overhauling costs because we were doing it more frequently. Spares inventory went up, and it was identified that almost 50% of the spares was actually not used in its warranty period. So you can imagine that spares of bearings worth several tens of lakhs of rupees, and they are actually sitting in inventory and not used until the warranty period gets over, so past its warranty period. And of course, the heavy outsourced labor. So these were the impacts of the workaround itself, right? So it definitely impacted the cost, but helped solve the main problem, which was of premature bearing failures. However, in spite of the workarounds, there were still few unexpected failures which happened within one period of because of the nature of the online CBM and how that actually benefited on a certain specific use case for their
Ronak, I'm just curious to note that because many a times these equipments are you cannot make an invasive cut or you can threading in the on the equipment. So how do you mount these sensors? Is it minimally invasive, or you have to make some grooves inside the equipment to fit the sensors?
So there are two types of mounting. One is a magnetic mounting, which is completely non-invasive. So typically, if you look at piezoelectric sensors are the single-axis piezoelectric sensors. They always come with a magnetic mount option. where you can just magnetically stick it on. This is what most of the time-based CBM technicians use. They have an analyzer with a magnetic mount for their piezoelectric sensor, which sticks onto the bearing housing and actually measures the bearing vibrations. The other one is using a vibration pad and sticking the vibration pad to the location. So now in this case, if you see the image,
Yeah.
if you look at the motor actually has mounts for measuring vibration. So those two mounts where you see where the are actually mounts for measuring vibrations. They're made for that,
Okay.
right? And a lot of motors, not all motors, but a lot of motors come with these mounts. And these are designed in such a way that in future, if you want to measure vibrations, these are the points to measure vibrations. And these are also as per ISO standard. Same for the gearbox. You can see it's exactly at the bearing location, right?
Yeah.
So that's how it can be done. It is completely non-invasive. So no technique requires it to be non-invasive. The only place we need to be invasive is for turbines. So for turbine applications, these sensors which you're seeing right now on the screen would not work. In turbines, you need something called shaft displacement measurement, which is something that Bentley Nevada does, which is a more high company from GE. Where
Your voice is
more
cracking.
invasive and it's more involved.
Bandwidth issue,
The entire
Ronak.
monitoring process.
Ronak, your voice.
Can you hear me now?
Sometimes, yeah, it is better. Yeah, it is better now.
Yeah.
Go on.
Yeah. So what I'm saying is that in some critical applications where you use shaft displacement and you want to right up to the bearing for the vibration monitoring, which is typically done for general hydrodynamic bearings.
I think again there is a bandwidth issue.
Becomes a little more invasive. But
I
for
think
most
just hold on, Ronak, hold on.
Non-general bearing.
Ronak, hold on. So I think there is some bandwidth issue. You might have to maybe if there are other users of internet.
Application can be deployed retrofitted.
It seems there is some network bandwidth issue. If you can ask, I'm unable to hear you clearly now. Earlier it was fine, but
you can hear me, right?
Earlier I was able to hear you clearly, but now in the last 1.5, 2 minutes, your voice is not clear. Maybe can you disconnect and reconnect, or maybe
just give me 1 second. Let me just switch my Wi-Fi.
Yeah, you can switch on, or maybe ask some other users of Wi-Fi to maybe disconnect for a while.
Hello.
Yeah, we can hear you now.
Just give me a minute.
Sure. Please go on. So in the interim, by the time Ronak joins in, I would request Sai Kumar Shanmugamji, if you are around. Sai, I'll just give you a brief introduction about Sai. Sai commands more than 25 years of rich media industry experience across industries and technology sectors. And he was the national head at the Economic Times Business Division, which is part of the Times of India group. And his previous assignment was as managing director and board member of the ITP Media Group, which is a UK and a UAE based group. He has consulted and advised over 1,000 plus global companies across sectors on business strategies and its execution. And as we speak, in his current avatar, he is the strategic advisor of Pro MFG Media. So I would request Sai, if you can just give us a brief about this program. You've been with us in these sessions, and a brief about your new venture. Sai, over to you.
First of all, thank you, Atul, for giving this opportunity. Also, thank Dr. Kamal Karnataka and CXOs of India, CIOs of India, as well as NASSCOM COE. I've been working with the manufacturing sector for more than 20 years. Earlier in Economic Times, it was a bird's eye view, but last 8 years, actually been traveling to a lot of manufacturing sectors and that is clusters of manufacturing industry. And we started a very innovative program. This is with the help of Aditya Birla Group, because 65% of their revenue comes in from manufacturing. They said create a knowledge-based platform where people can share their experience and learn from each other. So we started this program about 8 years back, and the format was very simple, that we used to invite plant heads and their team members to come and share case studies of best practices in terms of technology, innovation, cost, people initiative, safety. So these were so we ran it like a competition. And we didn't define manufacturing industries as such, but we said anybody in manufacturing sectors can come and share information. We were pleasantly surprised that there was so much of cross-industry knowledge pollination started happening. For example, when we were doing in Gurgaon, the SRF team and the AkzoNobel team had such valuable water conservation project. Maruti was so excited about it. They invited SRF team to come and address their employees about this. They had nothing to do in terms of the industry. SRF is into specialty chemicals and Maruti is into automotive. We also involved a lot of students from technical institutes to come and see what's happening in corporates, because we thought there is a requirement to bridge the gap between what is being practiced and what is actually being happening in the manufacturing sector. So we invited students from IITs, NITs, BITS and all to come and participate and just see what the corporates are doing. And these were full day events. We've been doing every year we do it in 6 clusters. So we've been doing for last 8 years. And it's like who's who of manufacturing sector, people coming and taking part. That was also, we were pleasantly surprised, because initially we thought people will not share knowledge. But like even in today's forum, what you have organized, we're pleasantly surprised people are willing to learn even on a Saturday and Sunday. And a Sunday morning, generally people do not sacrifice their Sunday mornings, but because there is so much of enthusiasm to learn, people want to improve their knowledge and see that how they can contribute well to the organization as well as to the peers. So, for example, the students also have a lot of good knowledge. When we had something, we had this session in Chennai. IIT Chennai students have done a very interesting predictive maintenance model. And the Schneider team from Bangalore had come in for this competition. They liked the project so much, then they got in touch with IIT Chennai and said that, can you help us in implementing this in Schneider plants across the country? Similarly, when a student from IIT Indore was there at Indore event, and the joint president of Ultratech procurement was there as one of the jury member for the competition. He liked the project so much by the student. He said, I have 65 plants. I have more than 3 lakh parts, the components which are used in these 65 plants. Some of them are legacy, some of them are modern plants. And there are thousands of vendors. And that's a big challenge for him as a procurement head. So he got in touch with IIT Indore and said that, can we do? So, so 7 of us.
I'm sorry, Sai, I'm so sorry. I was also interested. Maybe it'll be interesting for participants to learn about your current engagement with IIT Kanpur and what are you doing with the other IIT. If you can just give a brief.
I'm just coming to that, and maybe I'll just finish things in 5 minutes.
Yeah.
So what we did was 7 of us decided that there are so many gaps in the manufacturing sector which needs to be looked after, and there is a requirement. So past 1 year, we've been studying this. So what we did was we connected with over 2,332 manufacturing heads of organizations, said, if we create a digital platform, will you help us in sharing your knowledge? Okay. I've also connected in a lot of CIOs, whether they will like to help. And we also started talking to a lot of institutes. So there is another challenge came in from institutes. They've got government grant to set up R&D facilities like IIT Kanpur, BITS Pilani, IIT Indore, so many of them. The professors and the students are totally involved. The government has also given them equipment, the funds to create all these things what's required in R&D and help Indian manufacturing sector. What we realize, and since we work very closely with all these IITs, the professors and the institutes are not aware of the industry challenge. So now we have, firmed up our agreement with the BITS Pilani. We are in the final stage of discussions with IIT Kanpur, and we will help them in getting industry problem statements. So Pro MFG Media is the initiative what we have started. Amita, my colleague, is also a part of this forum today. She is the CEO of Pro MFG Media. And what we plan to do is connect with most of you, take your help in getting your experience and knowledge, okay, and create a digital platform where people can learn from each other. So in today's platform, what we have done using this forum also, IIPM has given in a lot of academic knowledge. Adani Wilmar and Deepak Fertilizer, and today we got from Dr. Ronak, the industry knowledge, okay? And it helps all of us in adding value in our jobs. And I see another benefit over here. IIPM's professors will benefit immensely by getting to know what is industry's challenge, because in their presentation, it was totally theory. They also mentioned sensors are very expensive. So now they will know that the sensors are not very expensive. They are affordable. So the students will get right kind of information. So what we try at Pro MFG Media is to bridge gap between industry, academics, CIOs and OTs. Like you are bridging the gap between IT and OT. We will also push the OT people to understand IT better.
Great.
So that we have a better manufacturing scenario. So that's what Pro MFG Media, we will be launching in December, and the website is under construction. And thank you so much for supporting us, even when we are just a startup.
No, I think great, Sai, and we will work together very closely, and we'll create value for each other as evolved associations should. Yeah. Thank you so much for your insights, and thank you, Amita, as well, for connecting me to you almost a month back, and we've brought this till so far. Thank you so much.
Thank you.
Over to you, Ronak. I hope your Wi-Fi setup is now done, so maybe you can take us through, please.
Sure. Apologies for that to everyone.
No, it's okay.
Can you hear me?
Go on, please go on.
You can hear me and see my screen, right?
No, your screen is not visible.
Just a second.
Yeah.
So can you see my screen now?
Yeah, now it is visible. Yeah. Carry on.
Okay, so apologies for that. So the second case study that I'd like to highlight is one of an O&M company. So this is Praj Industries, based in Pune, and they had a major problem where they were having sudden breakdowns of their dryers at multiple locations, right? And these dryers, basically, they have an O&M, agreement with the end customers. And the customers are typically, distilleries or other processing units, chemical plants or the processing units. And the output and the uptime of this dryer or of this piece of equipment is really of key interest, for this O&M company. And this is, I would say, fairly typical for most O&M companies, where O&M is about, providing uptime and providing the output of that equipment rather than just providing the equipment itself. Right. So that makes it more important to have reliability as an important part of this equipment. So this was the problem, right? I mean, dryers are very critical, in a lot of distilleries. And if the dryer breaks down, it really impacts the output of the distillery directly. So it's a direct impact on the output of the plant. So this is what was happening. It was happening at multiple sites. And what happens is, you have security deposits from an O&M perspective, and there are also penalties based on that. So it was a tough balance between having service teams on site, having these equipment running, doing the O&M contract, and also having to look at these security deposits and these penalties coming from the end customers. So of course, they did a workaround. They looked at how they can minimize this impact that they were facing. So obviously, having a larger service team is the first thing that they do. You have a larger service team, so you can go and visit the customer more frequently to check the conditions since you're doing the O&M. Possibly have people on site, with higher skill levels. Increase the availability of spares, so larger inventory of spares both at site and away from site, so that at least the MTTR can be reduced, so that the downtime is minimized. And finally, relook at the warranty terms or the O&M contractual terms that you have. So these are the typical workarounds that are being used by O&M companies across. And of course, this definitely helped. This helped the reduce the impact of the problem. But the problem was still there. So it came at a high cost. You still had increased repair, increased maintenance, increased overhauling, larger spare inventory. So it was affecting both top line as well as bottom line. So it was a keen requirement to ensure that this gets streamlined in a more reliable manner, rather than a workaround. So this is an example of the dryer. So this is a dryer. On the left hand side is a typical drawing or design of the dryer system. So you can see there's a motor, there's a gearbox, there's multiple couplings, and then you have the main gear pinion, and then you have the actual, the assembly with another supporting bearing at the other end. So totally there were 11 failure points in this particular piece of equipment, right? And any one of those could fail erratically at any point of time, and that was the toughest part of this. So this is a distillery plant in Daman, where this dryer has been installed. And what this O&M company did is they decided to, instead of having service engineers on site and having a high spares cost, they decided to monitor remotely. So what they've done is they've set up a remote monitoring center at their own office, and they've installed CBM sensors on these locations. All these 11 failure points, which they have classified, all these 11 failure points, they have installed CBM sensors, and they are now remotely monitoring this. So instead of having the service person on site or having extra service people travel to site, they are actually maintaining the entire O&M contract and providing reliability to the end customer with a larger, better peace of mind by actually doing this remotely. And there's a very interesting case study on this specifically. So this is what happened not too long back, actually. So in September, what they realized, once they installed all of this on their multiple dryers, this particular plant in Daman, they realized that suddenly there were heavy vibrations that were coming in the rotary and the bearing frequency regions, right? So you can see this is a very good before-after kind of a scenario, where the before is on the left side, the after is on the right side. So before the correction was made, you can see the impact that it was having on that piece of equipment. And this happened in a fairly short period of time. So within a few days, the condition of one of these failure points went significantly high, right? And you could clearly see that there was an issue with because of an alignment issue and a looseness issue, it was impacting the bearing. So the life of the bearing was reduced, not because the bearing was bad, but because the alignment had degraded. And because of a poor alignment, the life of the bearing was also going down, right? So the recommendation that was made to them was to first fix the alignment and tighten the foundation and then replace the bearings, right? I mean, that is also important, because you replace the bearings first, it's not going to help, because it's going to have the same, it's going to get degraded quickly anyway because of the poor alignment. So the team first went and fixed the alignment and the foundation and the looseness issues, ensured that was, ensured the initial portion of these frequencies, so the left hand side of these vibrations went down. Once that happened, they replaced the bearings. So then the bearing frequencies went down. And once both these fixes were implemented, you can see the drastic reduction on the right hand side. And now what this also ensures, because the root cause has been fixed, right? I mean, replacing the bearing is not really going to solve the problem. The root cause of alignment, which was causing bearing to fail to earlier than expected, since that is fixed, now the bearing will have a good life, as well as the equipment will have a longer life. So the sudden erratic failures, or the mean time between these failures, is going to get extended drastically. And because of this, now what this O&M company is able to do is they're able to view all of this remotely. So from their office, from their remote monitoring center, they can see their dryers, how they are functioning. They can see whenever something like what happens on this left hand side, if it happens, they can immediately, they know when to take action. So they don't have to send their service engineer every month, right? Or they don't have to have a service engineer on site. Whenever something like this happens, they send their service engineer. They know what to do, right? So the service engineer knows that, okay, it's an alignment issue, I need to fix the alignment. So he goes with the alignment tool to do the alignment. And you can also check whether the correction that you've done or whatever maintenance, that work that you've done, has it had an impact. So the effectiveness of your action is also a very important thing, because you could easily send a service engineer, he comes back, and then you have another failure. It doesn't make any sense. So the effectiveness of maintenance also extremely important, and that can also be checked as a before after point of view. And that is something that is now being done and being created as an SOP. So one of the most important things of deploying CBM, right, whether it is offline, online, or remote CBM, is that it should become part of the SOP. So there is a standard operating procedure that has to be put in. Someone has to be responsible for it, for implementing it, and for ensuring that the expected results come out. So like in this case, there was a person who was responsible for delivering this result. And that is why you are able to get such a good result. So CBM again is a tool, it's a strategy, it's a system, but it has to be utilized through an SOP to get the kind of output that is expected. And this was a very good way this O&M company was able to utilize CBM for their dryers.
Correct. Thank you. I think we can quickly run through the third case study, and then we can start with the IAPM show. Yeah, go on.
No problem. So the third case study, I just wanted to give you a perspective of what OEMs are doing. So OEMs are the actual original manufacturers of these motors and fans and other equipment. So the problems that are typically faced in brownfield projects post warranty are the same problems within warranty that are faced by the OEMs. So if there's a failure, if there's an issue in the warranty period, it is at the cost of the OEM. So heavy warranty costs is a big problem or a big challenge that they face, especially because of installation issues. And mostly OEM issues are all installation related. They're not really related to the design of the machine as such. And that is where it becomes very important for the OEMs to ensure during warranty period that there is nothing wrong that is happening. So there's an example of an OEM of process fans, one of the largest process fan OEM in India. They make fans for cement, steel, and these kind of industries. These are typically FD, ID, PA fans, exhaust fans that are used. So what they've done is they've started, within their warranty period, they've started deploying what they call smart fans. Right? Smart fans are these fans which are inbuilt with CBM upfront, right? So CBM means they're looking at vibration levels, they're looking at frequencies, FFTs, and during the warranty period, giving a better result, to the customer. So the customer is more, has a better reliable solution, and they don't have to worry about any potential breakdown that happens. And this is an example of a smart fan deployed at a sinter plant, where the fan OEM is able to identify that after installation there is an unbalance in the fan, and can fix that upfront before doing the final commissioning, right? So that when the commissioning is done, all of these aspects of during installation are taken care of, so that there is no impact during the warranty period, which is good for both the OEM as well as the end user. So, Atulji, in interest of time, I'll stop here. I hope that answers the request that you had for a few more case studies from the participants.
Yeah, it does. Just one aspect. I just want to bring out. There was a question that how does all of this monitoring help in improving the OEE, which is like a factor of availability, performance, and quality of that equipment.
Yeah.
So how does this have a bearing on the overall OEE of the asset?
So there are two aspects, Atulji, here. OEE, the availability part is, a direct impact, right? The moment you have CBM, you have better availability. So straight away, the availability factor can shoot up once you implement CBM. But secondly, which is also interesting, is that the performance can also be improved. a lot of times, and we've seen this sometimes in some steel industries where you have the mill, or you have certain, the OEM who gives you the entire rolling mill, or any of these process equipment. They rate it at a certain speed in terms of throughput, or in terms of speed at which it should be run. And over time, as the parts degrade, typically a lot of companies run them at lower speed. So typically they run at 60% of the OEM rated speed, or 70% of the OEM rated speed, which is the max speed. And really the reason to do this is the optimization between maintenance and production, right? I mean, you don't want to run it too fast on an old OEM equipment, because you are scared that something might fail. When you're actually monitoring everything real time and continuously, one of the other levers that you have is to actually increase the speed of production. And we've seen this both in process industry as well as discrete manufacturing. In process industry, it is increasing the speed of the line, which can give you a better throughput because you know the condition of your equipment. In discrete manufacturing, in metal cutting operations, when you're monitoring the spindle condition and you know what is the load of the spindle based on the vibration data, you can actually increase the cycle time, improve the cycle time. So you can make more parts in the same amount of time, which will improve your throughput. So both, it can impact availability directly and throughput indirectly.
Very nice. I think very well said. And I'll just add one aspect to it, that we always talk about asset utilization, sweating the assets. We often use it, and you would have heard it most of us would have heard it in a lot of these webinars and these seminars. But if you were to use a similar asset or a tool to monitor your assets for condition monitoring, so not just you look at the condition monitoring aspects, but you also look at the utilization of that asset through the day, months, through the year, so that you can know which asset is used 10% of the time, 30% of the time, 70% of the time, and you can use this data to defer some capex also. If you were to increase the capacity of the plant, suppose for some reasons you have to increase the capacity or the throughput, then you can look at what is the current asset utilization, and then you can always plan the refresh. That also is a perspective. Thank you so much, Ronak, for your insights. I would now request Barik ji to please take us through his presentation and share his learnings with us.
Okay, thank you, sir. Just now I'm sharing my screen. Just help me whether it is visible or not.
Barik ji, abhi aa nahi raha. It says you have started screen sharing, but it has not come.
Okay, pause a little.
Did you ask someone to help you out with the antivirus settings?
Just a minute, sir.
Yeah, sure. Take your time.
Stop
so
sharing.
In the interim, I would request Ronak, there are a few questions on, have you seen instances wherein OEM vendor accesses the CBM data remotely and actually guides the plant operations and maintenance team to do or to take corrective actions, or basically takes the action through his or her team? Have you seen these teams also catching up?
Yes, Atulji, it is still early days for the OEMs into remote CBM as such. Online sensors, having sensors, piezoelectric sensors on motors has been going around for a while, which integrates into your local DCS system. But remote CBM is something that has come up recently. Crompton has started doing it, Crompton Greaves. In fans, Rides is doing something very interesting. Rides, which is making process fans. They are doing really good work. And there are, and of course, the bearing manufacturers, bearing OEMs are doing a lot of work. Pump OEMs are also coming up. Kirloskar as a product, as a solution, a remote monitoring solution of their own. So the OEMs are starting to give these kind of things. The initial way of doing it is through their own AMC contracts or as part of their warranty requirements. and then the end user starts using it post warranty period or post AMC period.
Okay, there's another question that how do you gather this data, because one is the sensor part, but then you need some transducers to convert that sensor data into from an analog to digital form, and then relay this data into a platform or into a setup wherein you can do some computation, put some algorithms and derive some outcomes out of it. So do you need some kind of SIMs, or do you do it on a Wi-Fi setup? How do you do that? How does that architecture work? If you can just give a brief till the time Barik ji connects.
So there are multiple types of sensors. What we work on typically are sensors which are Wi-Fi enabled, right? So because they're Wi-Fi enabled, if you have a Wi-Fi environment, they can straight away transmit data. So it's a very simple architecture.
Okay.
If you look at piezoelectric based sensors, you have to take that data to a common gateway or to a common converter, which converts analog to digital and then transmits that data. So it's an extra step. So it depends on the type of data source you're looking at.
Okay. So either it could be you have both these options available. You have the Wi-Fi enabled sensors. Some categories of them are Wi-Fi enabled, and some have to be connected to a gateway. And that gateway can have a SIM or a network connectivity to take it to the central hub, so to say.
Absolutely. So if you, in some cases, some plants you already have piezoelectric sensors. Typically, cement plants and power plants, they have vibration sensors which are single-axis piezoelectric sensors. They don't have the FFT part, but they already have the time series analysis of these sensors. So that can be connected to a DCS system and taken to a platform.
Great. Taken. I think Barik ji, has he joined already, or let me just see.
Sir, just a minute. Give me just 1-2 minutes more. I will come back again.
No, it's okay. Take your time. In the meantime, we are clearing the queries and questions which are there. And
I will inform you, sir. Okay, I will inform you. Okay.
Yeah, go on. Sure, go on. So I think there is another. Okay, so another question is that can we have some information on companies who manufacture these sensors and share it with us here so that we can use it in their own setups? Ronak, any thoughts on this? And you can be as neutral as possible, maybe.
Yeah. No. There are two types, like I said. It depends on if there are Wi-Fi based sensors. There are fewer companies who are doing Wi-Fi enabled sensors in this space. In that, again, there are two types. One is the battery operated, one is the powered. Both have their pros and cons. And then in the non IoT sensors, you still have standard sensors. Piezoelectric sensors. Where you can actually connect these piezoelectric sensors to your DCS, and once you have all the information on your DCS, you can actually take that to a cloud-based software or a platform like ThingWorks or any of these others. So there are a lot of, it depends on if there are existing sensors and if you are interested in piezoelectric sensors. And again, like I said, turbines where you have journal bearings, where you have hydrodynamic bearings, you would need a more high-end solution like a Bentley Nevada or a Shinkawa. For balance of plant equipment, you don't need that. You would need something more cost effective and scalable and deployable at scale.
Yeah.
So we can come up with a list of available technologies, Atulji, and in all neutrality, have that shared with the rest of your teams through NASSCOM.
So another question was that I think do we have I think Amit, are you there? Can you hear us? Amit Saluja? I think we have Amit from NASSCOM. He's there. I think he's on mute right now. Maybe he'll join us in a while. So there's another question. Let me just take this one as well. Just hold on. So there was this question around how is data currently collected by industrial engineers to make day-to-day data-related decisions, or so how is the data getting collected and disseminated, so to say, because one is the collection of data. How does it relate to the right team members for them to take a call that what do they need to make any corrective actions, or it's everything is fine?
My understanding of the industry is that about 80% of the process industry uses manual data collection. So you have handheld vibration probes or vibration analyzers, typically from either SKF or from Emerson or any of these kind of companies, where you actually manually walk to every machine and measure the vibration and the spectrum from each machine. And based on the spectrum, the data collector then gives this data to a data analyzer, who then analyzes the data and gives a diagnosis or a recommendation, to the company.
Understood. Okay. Acha, another point was, I think Mittalji had a point that no, if we were to install the sensors inside the equipment, then will the warranty get lapsed? I think the invasive kind of sensors, specifically in the case of turbine, as Ronak already mentioned, those are different category and variety of sensors. Like he mentioned, Bentley Nevada supplies it. So does Shinkawa. Earlier days, we had this IRD also who used to supply these sensors. So, and the sensors which we are talking about today are either installed on the pads, vibration pads, which are pre-installed or pre-set up in the equipment, or they are magnetically coupled. So it is not an invasive threading which needs to be done, which can have a bearing on the warranty, so to say, warranty or even the performance of the
Correct. Absolutely.
So I hope, Mittalji, it answers your question. I think broadly we are covered, and I would request Parik ji, if you are there, maybe if you can share the presentation with me, and I can, or maybe you can use Vishwajit ji's system to showcase the presentation or run through the presentation. Vishwajit ji, are you there? Or can you help Mr. Barik to relay his presentation from your system? Because yesterday it worked very well. Let me just reach out to him. So there's another question I think Abhay has, that no, there are reasons which are not related to CBM. That is, there are no orders, no material or spare, or you're not running on the rated capacity, or there are labor issues. Yeah, of course. I think that's not a question. I think, but it's more of a view that no, if there may be a situation wherein you don't have orders, or you do not have raw material, or you don't have to run at the rated capacity. Yes, of course. That's fine. Yeah. So I think what is the key factor of OE calculation? If you can just put it on, one of you maybe can put it, maybe Putta can put it on as a response, so that no individuals can take a note of it on the chat window itself, because no, it will get recorded and captured there.
Sure.
Just reaching out to the IIPM team. Give me a minute, please.
Yeah. And in the meantime, you can ask the question which are there in question and answer box.
Sure.
Yeah. I was just about to step in. So I think one of the relevant questions says some insights on the cost of implementation, maybe at a high level. It's come from Nikhil. So also on what platform the data can be monitored and analyzed. So that's a relevant question, because all CIOs, I think, are concerned about the cost of such implementations. So, yeah. Dr. Ronak, could you please give some inputs on that?
Sure. So typically, cost of implementation for the IoT-based CBM systems starts from around I would say 700 to 800 rupees a month per bearing point. And it can go up to around 2,000 rupees per month per bearing point, depending on the vendor. So there are multiple options in the market. On the non-IoT based CBM, which is the online, typically a single axis piezoelectric sensor comes at around 15,000 rupees. The sensor itself, the piezoelectric sensor, plus the cabling to the DCS system, is the extra cost. And apart from that, of course, if you need triaxial, you need about 3 of these per bearing point. So that's the approximate cost. And if you just for comparison, a typical analyzer, which is the portable analyzer which a person uses walking to each and every machine, a portable analyzer again starts from around 12 lakhs to about 25-30 lakhs, depending on the type of analyzer and the quality of the analyzer. So if you look at multiple brands, Emerson right up to SKF, ABB, Siemens, they all have analyzers in that space. So I hope that answers, in the question.
So this is the all-inclusive, includes all the software analytical components as well as the actual sensor in an OPEX model?
Yes.
Okay. One of the questions is, will the warranty not get affected if sensors are applied inside the equipment, like in case of turbine?
So in case of turbines, most turbines actually come with sensors, right? You just have to connect the sensors to the platform. So the drilling and all of the invasion is already done in turbines, because turbines are so it comes in a class called supercritical, which is one step beyond critical. So turbines and high-speed compressors, these two category of machines, they come with sensors as default.
Okay, thanks.
Yeah.
Yeah, and you can go on with the questions maybe.
Yeah, I'm just going through the questions. One second. I think the other Q&A questions are already. Do we have a platform where this case study is available for reference?
I think I can answer that. What we'll do is, as a follow-up of this session, as we discussed on the very first day, we will send out some of these important relevant case studies with all participants. And there is a survey on a feedback form which Kamal will share in a while. Kamal, if you can share it now. So which we would request participants to fill in. And it is important for them to fill it because the certification will have the same name as you will fill in this form. So please do fill in that feedback form, and once you fill that, we'll send out the case studies as well on the same mail ID.
One of the questions which has come from Manzar is, I'm trying to understand how to do auto compensation as feedback loop from sensors on quality station. I am not sure I fully understand the question. So example tool auto compensation.
Yeah, so this is, I think, specifically to metal cutting machine tools, where you have tool wear that happens, and then you need to take tool offsets and compensate for the wear of the tool to get the same quality. If that is the right understanding, then
I expect so.
Yeah, if that is the right understanding, then basically all these IoT sensors, although they send data to cloud, at least the ones I know of, only the one we make, at least it connects also to the PLC through RS485. Most piezoelectric sensors have 5 to 20 milliamp output, which you can connect to a PLC, and you can actually use that for auto compensation or correction. Pure IoT sensors won't work for this kind of application because the data goes to cloud directly, and then from there you have to take the auto compensation, which is a longer route, which may not be fast enough for a machine tool application. So there you need to have a local integration.
Yeah, I think we have gone through most of the questions, Atul, unless you see something.
I think there's one which could be of interest, is which the question around the reliability of these sensors itself, that know how reliable these sensors are, and how frequent how can we face failures, or what is the mean time between failures of these sensors, so to say.
So I think to answer that, see, piezoelectric sensors have been an established product. They are fairly robust and mature over decades. So you'll face very, very few failures in piezoelectric sensors. When it comes to the more newer age, IoT-based products, the very fact that they are new, the MTBF are lower, and over time, as the products become, as the user acceptance and the base becomes larger, automatically over time, these products will also become equally mature and robust as the piezoelectric counterparts.
Yeah, one more question which I think we can pick up. This has come repeatedly. MCSA, if you can throw some light on MCSA plus voltage analysis as a technology for CBM. There's a claim that they can be next level in accuracy than vibration analysis, motor current signature analysis. So,
yes, see, motor current signature analysis is very useful. The only issue with that is, if you look at a per application point from a cost perspective, it's a little prohibitive. But actually, MCSA is a very good technique. It's also been around for a while. It's not a new technology. It's also been around for several decades, and it also has the same concepts of harmonics in the current spectrum, which can help diagnose specific faults. So it's just, I would say it's a technology improvement that on that front to make it cost effective and scalable, that is really required to make it something that can be deployed at mass scale.
see, I have a question. One of the examples which we had seen was where you could identify which component failure also based on the vibration data. So, but does it not take a lot of time? So, is there any standard data? It could be a very layman kind of question, because I struggle with this when we're trying to look at the power consumption patterns that not have access to a standard database of different makes and models. What is the benchmark, and against the benchmark, how is our data comparing? Because otherwise it takes a long time to have some analysis, right?
Yes, that's correct. So basically, there are some ISO standards. The most commonly used is ISO 10816. So the 10816 standard has many sub-standards within it. For motors, compressors, even in compressors, there's rotary compressors, centrifugal compressors, screw compressors, reciprocating compressors. So this ISO 10816 standard is fairly all-encompassing, where it looks at all the different types of rotating equipment and what are the benchmarks that have been created from an ISO perspective. Again, these have to be taken with a pinch of salt. You can't just use the ISO standard as is, because there's also certain things like, your foundation is fixed, or is it a damped foundation? Is it a flexible mounting, or is it a, concrete mounting? So these things also have an impact. But yes, there is a standard which is available. For bearings, there are libraries of bearings. So each bearing OEM has made public their bearing frequencies, right? And for example, we have tied up with all the bearing OEMs to get that library. Similarly, you can get those bearing libraries which gives you those fault frequencies for each bearing. So there has been a lot of work done to standardize benchmarking and identification of these faults as soon as you start deploying CBM, rather than having to wait for a long period of time to benchmark and then get some results.
So if we come on to an infinite uptime kind of solution, you're saying that based on our, what the data captured from day one, we will be able to get some analysis on the likely fault, or will it take some time to ramp up to that level?
It will give you immediately. So for example, the Praj example that I showed you, right? The recommendation to fix the fault was made within 11 days, actually. Within 11 days, and then they made that fix, and then the before after difference was seen. So it can be fairly quick because there are some basic standards which are already there.
Okay, thank you so much for that. One more issue, which is a question which is being raised, is if it is a Wi-Fi based system, store and forward option is not available. So if connectivity is not there, the data streaming will be lost. So is there any, I mean, if you're transmitting directly, is there a chance of data loss?
Yes, there is a chance of data loss. This is with all IoT-based sensors, especially continuous real-time IoT-based sensors. So vibration, especially being a high-frequency data, it uses up a lot of space in terms of storage. So in case of these kind of, especially in CBM, yes, it will result in a loss of data. But you have to look at it from a perspective that typically you're going from data once in a month to pretty much real time. So small drops in Wi-Fi shouldn't, are expected, I think, all across India. We know how the Wi-Fi is. You saw how my Wi-Fi is when I started this discussion. So that is an issue that could come up. A lot of companies are installing their own Wi-Fi networks in their plants. I've seen this in many plants. Right from Tata Steel has done that. A lot of plants have started doing that.
So I think by the time, hello, Ronak, can you hear me?
Yes. Go ahead.
Yeah, so I think in the interim, our Professor Barik sets his screen up. I've asked him to share his presentation with me, and so that I can relay that presentation from my setup. I would request Putta, if you're around, if you can just take us through a brief about these case studies, and I'm just introducing Putta, whose full name is S.R. Puttalingia, and he works as a global condition monitoring head at Infinite Uptime, and he's a Bachelor of Engineering in Instrumentation and Electronics, having 22 years of experience in condition monitoring. He has worked with companies like Emerson, and wherein he set up the complete condition monitoring practice from scratch, and they used to monitor around 16,000 plus wind turbines globally. So that's what is the scale of experience he brings in. So Putta, if you can just please take us through by the time Barik ji sets his system up. And I think we have made the most out of this time. I'm aware that the IIPM session could not be done, but at least we've been able to get some practical insights from both of you. Over to you, Putta.
Yeah, thank you, Atul, for the introduction. I hope you're able to listen to me.
Yeah, we can see you and we can see the screen and hear you as well. Go on.
Okay, thank you so much. So, yeah, so I'll just, due to the interest of time, I'll just give you an overview of the CBM. So as Atul introduced, I come with the core field of experience in condition monitoring. I take off around 22 plus experience in this vibration field. I saw the journey from past 20 years, how this evolution is happening, and which is making me more active and taking me to learn more and more in this subject. And in the past, I'll give you a brief idea how it was been taken up. Before that, as Atul has already introduced, in my past experience, I was spending good time with Emerson for 17 years in the past. So where I did maybe 300 plus installation on a offline condition monitoring with various organizations, as well as I imported this condition monitoring training to more than 500 people when I was with Emerson earlier. And having a good knowledge and established the offline contracts in condition monitoring field, as Dr. Ronak was saying, there will be workaround people who give contracts to outside people who can collect data and do the analysis. So that's sort of an arrangement also I hold the experience in implementing it in the past. Later, I was with Vestas for monitoring wind turbine remotely. And wind turbine monitoring is also very crucial because maintaining the wind turbine is a very challenging and it's a very cost effective. So there, the vibration monitoring is the key role here because so whatever we are able to identify the problems which are at the baby stage can be made uptime repair. So making a wind turbine uptime repair is a very key factor in cost saving. So also not only solution for wind turbine. The same way, then I joined a company called Infinite Uptime. So here, the new trend that has coming up now, that is IoT solutions. So I head the operation team for India, and I'm also managing the south and outside India sales here. So I've been, with my experience, like we have been improving this product day by day, and it has come to the matured way that it's supposed to be. So this is my as me here, and to have more condition-based maintenance, or rather I can say condition-based monitoring, the main things, it requires three processes. One is technology, of course, and the people skill and the communication. So in the today's environment, the sensor which are mounting on the machine, if they are able to talk what the pain they are undergoing, that is really making a step ahead in understanding the machine behaviors well in advance. So if you make these things in rightly placed, so like you can maintain the equipments in a very good manner. So I also give you a brief evolution on this condition-based maintenance, like as previously a few colleagues of mine already told. Offline is implemented, but if you take the pros and cons here, it generally is used for less critical assets where periodic scanning is good enough to observe the current condition. But the challenge you will face here is that what if something is going on there and you are not in the schedule? Atul, I hope you are able to listen to me.
Yeah, Putta, we can hear you.
Yeah, sure. Thanks, Ranak. So the cons here is that there will be repeated skill people change, and as well there won't be any improvement in the schedule-based data collection there, because whatever the frequency set, it has been doing, and it will be continuing to be doing it later, but never takes a challenge to reascertain that frequency, whether that's correct or wrong. So that due to the outsourcing, this will get fail here. But if you go with the online solution, yes, this is gives a very good idea and a very good condition status. But the fact, what happens here is the cost. So it is very sensitive on the data. If the unmanned skills are there, then probably the data what is coming from online will not be able to read properly. So you will end up in having a very high skilled people expertise is very much required here. And then later on, the evolution started with wireless solution. Yes, this wireless solution will give us the automatic schedule based intermediate updates. But what happens is the solution implementation comes with a costly as a cons point.
So I'm sorry, Putta. I'm sorry. Yeah. So my request is, in the interest of time, if you can just, we've had a brief about it. You can go to the core solution or the 24/7 thing, so that we get a clear view about the aspects, and then we can quickly have a brief about the CBM aspects from Barik ji also.
Yeah, sure. Yeah, thanks, Atul. See, so with my journey in this field, the CBM in the current scenario of COVID-19 is that like people have to go with this scalable solution as an IoT today, which is coming up now, which will like many plants are running 24/7, and even at highly uncertain level, plant has to run. We cannot stop. So in that cases, so this IoT solution becomes the very vital and a very important role now. So the future is automation. So this IoT solution is an automation where you can teach the sensor to detect the particular problems, and it can give you those information well in time to the site people and the maintenance people and the management people. So they are all get aware one at a time, understanding the need of the risk which is going to come. They can plan it well. So definitely they can reduce the unplanned time, and then definitely give the uptime more on those plant equipment. So one of the previous experience what I had, like as I was mentioning, wind turbine has to be monitored remotely. So when you install the sensors remotely there, Now this is a solution. This is one of the case study where I'm showing you from the wired solution. So now this wired solution can be scaled up to this IoT solution very easily now with a very minimum cost today. So in this example, I'm showing you the 3 months time data, the scalar that has gone up very rapidly, and one can able to identify what's going on in the equipment there, and we can plan the maintenance activities in the proper way. So my point here is that, so whatever this solution we have today with the wired solution, or maybe a previous with coming with a premium cost, can be can be applied with IoT solution today to capture the same result with a very minimum cost here. The savings I need not to mention. I just show you an example over here. So the savings is going to be very high in the wind turbine applications if you're adopting as a huge on IoT solutions today.
This is almost $99,000. This is 99,000 euros. It is not 99. Yeah. It is not 99 euros. We need to
99,000 euros.
Yeah, correct. So I'm just, because there's a decimal, so that no people don't read it as a just around 100 euros. So I'm just mentioning that.
Yeah. Thanks for correcting, Atul, because in the Europeans they write it as.
I know that. I know that. I'm aware. Yeah. Go on.
Yeah. Thanks. So the role of CBM in Industry 4.0 is that plant integration is the key factor in Industry 4.0. Employing integration communication technologies can help connect data from various points, and that will help to take the decision very faster way. And now equipment can talk what they are coming up and what the health is undergoing, and it can be monitored 24/7. So the future is the more you do automation, the more you make independent without human intervention, and you bring those data to get a meaningful decisions. So this way, surely the CBM will be in the next roadmap if you're using the IoT solutions on this line. I think many have already shown case studies here in one of the crusher plant, steel plant, where we have installed on the motor crusher, where this the crusher feed has to go to the boiler area, like blast furnace area. If this crusher motor fails, the whole blast furnace area will stop it. So, but due to the safety and other norms, the offline data collection and wired online solution will be a costly proposition. Knowing this IoT solution, they imported this IoT solution. So with that, they could be able to identify the motor health remotely, and they took the decisions fast to understand what maintenance needs to be carried out there, and they imported. So what I can say is that mean time to repair has been reduced a lot, which was taking longer time in the initial days. So now with this, they got the benefit, and they got the solution over in the steel plant here. So similarly, in one of the aluminum refinery, there is an AFG exhaust fan, where offline data collection is also very not a safety manner to collect data there. So they have installed our sensor there, and the IoT sensor, and they got the benefit by knowing the health status of that fan, and they could do the maintenance during the opportunity. And with that, they have reduced a lot of downtime there. So with this, over to you, Atul. This is all I have in my experience status. Hi, Atul.
Hi. Yeah. Thank you. I think good. I would request Kamal, if you can just please take up the presentation of Professor Barik, which is there. Kamal, if you can just relate on your screen, and then I would request Professor Barik to take us through. I would request him to, in the interest of time, maybe try to cover just those critical aspects in next 15-20 minutes so that we can conclude in time. And those who have not completed this survey till so far, please do so. And also share the address, the mailing address, so that the certificates can be shared on that address. And Amit, if you are around, maybe you can help us out with the closing remarks along with Kamal.
Hello.
Yeah, Barik ji.
Hello.
Barik ji, आपका आवाज आ रहा है.
You got it, sir?
Yeah, we
got
it,
it,
we got it, and now Kamal ji is presenting it. Yes.
Now I will be here, or
I'm still to get it, Atul. Not yet got. Barik ji, you can start as soon as I get. I will start it. Yeah.
okay. I am continuing.
Yeah.
Initially, you start thermography PPT. Okay, sir.
Okay.
Yeah. कमल एक बार आप देखिएगा आपके जीमेल आईडी पे मैंने भेजा है.
Just a minute, it is coming, I think.
Okay. Sir, good morning all panelists and my dear beloved participants. In the first day session and the second day session already we have covered introduction about the maintenance philosophy and condition-based maintenance philosophy as well as vibration analysis. Okay, sir. So today we have a plan to continue. So initially thermography, then we will go for wire debris and vibration. So before displaying my PPT in the screen, so let us start. What is thermography? There are so many condition monitoring technology nowadays we are using.
I think it is visible now.
So next slide, please. Next slide.
Yeah, the screen is visible. Kamal, you can take us.
Yeah.
I will continue, or sir will continue. Okay.
No. You continue, please. You continue.
Okay. So okay. Regions of the spectrums. Not in our naked eye, we cannot nothing but a condition monitoring.
बॉस अब आपका बैंडविड्थ का कुछ इशू है क्या? आपका आवाज ब्रेक कर रहा है बीच में.
Means, hello.
Your voice is cracking in between. It's not continuous. आप अपना वीडियो बंद कर दीजिए थोड़ी देर के लिए. You can switch off your video, please. Maybe you can just keep your audio and so that the bandwidth.
No, already video I have stopped. No, already video is stopped, sir.
Correct. It is perfect. You can please go on.
Video is stopped.
Perfect. Kamal, maybe you can start the presentation.
Yeah. I'm doing it. Yeah. Just...
Please display.
Yeah. Just 1 second.
Yeah.
Okay, full screen, please.
Yeah.
Okay. So next, please. Next, please. So mainly it is every instrument or every machine has a principle or working principle. Similarly, thermography has certain principles. So that works with the infrared radiation principles, because what we are not seeing in our naked eye, that can be seen through the thermography camera. Thermography is the study of heat patterns in a particular region where when the infrared radiation exit out or emit from the machine surface, that will capture by the thermography camera. Then that camera that pattern display in the camera in the display screen like a thermogram. What is thermogram? That means color palette with some hot spots or a hot line or a hot area in terms of temperature scale. So next, please. And what about hello? Next, please.
Yeah, just doing it, boss. Correct.
Next, please.
Kamal, next screen.
Next, please. Okay. So when we are suffering in the fevers, just like a doctor, fevers monitoring the temperature and diagnose the temperature. According to the temperature range, he decide which kind of fever the patient is suffering. Similarly, in the machine from the surface, whatever the radiant energy emit, and that captured through the thermography camera. So that condition monitoring or thermographer or thermography consultants or analyst, which will analyze from the data taken by the thermographer and diagnose the what is the by seeing the hotspot or hot line or hot area within the temperature scale, and by calculating the change in temperature or increase in temperature, then decide what is the fault and what is the fault happening in the machine component or externally or internally. The temperature provide an excellent indication of the condition equipment. It is ability to thermal camera to see the early stage of increasing temperature. That means from the hotspot or from the temperature and palette of the display screen of the thermography camera, what will be recorded or saved by the thermographer. So we can see in the bottom line there are two pictures. In the panel cabinet there is a cable cabinet in the bottom of the panel. So you see that is taken in the normal camera, but in the right side picture shows in the thermography camera. So what we are finding in the naked eye, whatever the radiant energy emits, so we cannot see this. But in the thermography camera, the record photography or picture or thermogrammy. So in the out of three phase R, Y, B, in the B phase we are seeing the different colors, and the total picture in the consist of different colors. Blue regions are cold, and white hot, and white red and white stage are very hot. So in this phase there is a problem, maybe joint problem, joint looseness, maybe corroded, maybe pitted, maybe contaminated substance. So okay. So before entering into the thermography world, so let me tell you what is science of infrared image displaying in the thermography camera by through the help of hotspot. We can judge the so many faults. So what is thermocam? Thermocam is nothing but thermography camera, which is used by a thermographer to record the or collect the data as well as thermogram from the different machine of the industry or any object surface. So what is thermogram? Thermogram is nothing but a pictorial view or photograph which consists of so many colors or palettes in terms of temperature scale. And who is a thermographer? The thermographer is a person who is handling the camera. He is responsible for the all sorts of recording the data and thermograms, and also save all these things. Then it will be analyzed, interpreted, and recommendation suggestion is given by the analyst. The palette is nothing but your next slide, please. Next slide. Nothing but are different colors. Maybe in the thermography camera. Bishu.
आपका आवाज आ रहा है? कंटिन्यू करिए बारिक जी. बारिक जी.
Thermography. ये क्या? Are you listening?
Yeah. We are listening.
Is it audible?
It is audible. Continue.
Okay. I am continuing. Sir, if before slide, just me focus something. Previous slide, please. Hello. Is it audible?
Yes, you are audible. यही है ना previous slide.
Yes. Yeah. This is previous slide. So thermography. Just after next please. Next please. Hello. Okay. So next. Oh, so
थोड़ा ब्रेक, थोड़ा पॉज लेना पड़ेगा क्योंकि रुक के it takes a while to update the slide.
Yeah. It's okay. It's I'm getting. So is it full screen?
It is full screen.
Okay. So before handling the thermography, is a thermographer as those are the thermography. So actually what happened, so it works on the different principles. So principle is that is one is your that is propagation of heat. So here and more transformation of heat. So it consists of emittance, transmittance, infrared ray, and reflected ray. Energy emitted, energy transmitted plus summation of energy emitted and energy reflected must be equal to 1. In some cases, whatever the radiant energy emitted from the surface of the object or machine, it will
बारिक जी, आपका आवाज जो है ना बीच बीच में ब्रेक हो रहा है. इंटरनेट कनेक्टिविटी आज इंटरनेट कनेक्टिविटी का प्रॉब्लम है आपके उधर.
Everybody in the world.
बारिक जी, can you hear me?
Atul, can we look at an option of getting a session recorded by him and sharing it with everyone?
I think that is something good. That's what I was wondering, because I'm at least unable to hear him clearly.
Yeah, there are patches and it is not being a great. So maybe this is one way that he can record his session and send it across to us.
वो कर लेते हैं. I think let's do that.
I think
and I would request Amit Saluja. Amit, are you there with us? Can you hear us?
Yes, Atul, hi.
Yeah, hi Amit. So hi. So those who do not know Amit is the head of Center of Excellence for NASSCOM. So Amit, because of this net connectivity issues, we could not complete the IIPM session today. But I think we got a very good perspective both from Ronak and Putta on the case studies and the solutions they've deployed till so far. And would like to hear from you, because you've been engaged with a lot of these other startups also, and you have this view around how predictive maintenance techniques and condition-based maintenance techniques are being leveraged by industries at large. So maybe you can give a brief perspective, and before we conclude the session for the day, and I will ask Kamalji to give the concluding remarks. Amit, your thoughts, please.
Sure, thanks.
Hey, sir, are you audible, sir?
So I think अभी बारिक जी अभी आपका अलग से सेशन कर लेंगे. We'll do a plan a session because your voice is cracking. So we will take it up later. बारिक जी. ठीक है. Over to you, Amit. Please go on.
Yeah, sure. This has been a great session. I think the way all the three sessions have progressed from the kind of a thing, I think it's been great. Now coming to the like what you said about the condition monitoring. It's great to kind of learn about the different technologies that are available to do the condition monitoring. And my thoughts here is condition monitoring is basically a first step towards doing the predictive maintenance. Right now, the challenges that we are seeing along, I mean, like we keep talking with a lot of manufacturing leaders and with the startups, and during the visits, many times it comes up is a lot of companies are still doing the data collection manually, which is always becomes a kind of a challenge. Now, how do you then we don't have a historical data which is available. At least, I mean, like for doing any kind of an analysis, you need 5 to 6 months of a data. But in the most of the current scenarios, like we found that due to the manual kind of analysis, the data is not available. So these kind of technologies which are there for the long, but I think not been effectively utilized. I think this can give a great value to the manufacturing organization in terms of really planning the whole maintenance of it, and then saving the any kind of a downtime which is there. In fact, whenever there are a lot of startups right now who are working with NASSCOM, and they are into implementing these solutions with the manufacturing plants. And that's where the most of the time it comes up is how do you first start getting the right amount of the data. And the different technologies which has been explained today, like whether it is thermography or it is the vibration, correct? We also talked about the using the current measurement also when this can be done. So I think each method has its own benefit. But one of these technologies based on the kind of an assets which we are actually using, I think we should kind of go with it. The IoT technology has kind of really made it very kind of easy to implement it. And right now there are not much of a security issues also what earlier used to be there. Now these solutions, IoT solutions, are much more secure than it used to be earlier. So that already security element is taken care. So I think these technologies are very valuable. What we needed was this kind of a session on the awareness of it to the kind of leaders within the manufacturing companies. I'm sure they will provide a lot of value and to them, and a lot of thoughts will come up on what should be the next step on moving forward. So in the digital journey, this is the start of the condition-based monitoring is the start of the technology.
Great, thank you, Amit, and thank you for the great insights. And I also want to just highlight that while on one hand all of us are talking about these autonomous cars, machines, but on the other hand, in many of our setups, in our manufacturing setups, we find manual collection of machine data being done, and which requires excessive manpower, so to say. And it also results in capturing data at an intermittent point of time, which makes it quite possible to miss out on monitoring of the critical data. Because if you monitor every month, then maybe you miss out on the other aspects of the machine's condition. And then what you also find is that the technician goes around the shop floor or the plant periodically, collects data using a data collector, and it's not useful to drive prediction, so to say, because it has multiple limitations. But as we see the predictive maintenance techniques, as we just showcased, it can provide not just peace of mind, but sometimes a machine outage can bring a plant or a plant section down for several months together. And then safety, reliability, they are all intertwined, as we know. And if you have the early detection of defects, you can lower the overall equipment failure cost. So to say, there is a saying, a stitch in time saves 9. And with these advanced warning systems and with online systems sensors installed, companies stand to benefit out of it. I think great session from IIPM team, great session, and thank you again to the entire team. I request Kamal Karnatak ji, President of CIOs of India, and the Sutradhar for these sessions to please guide us and take us through the closing remarks. Kamal ji.
Yeah, thanks Atul for this wonderful moderation. People are praising your moderating skills, so it's good to have that. First of all, apologies to all the participants. We could not complete the full session which we have planned, but this is the technology. We all know that whatever 5G, 3G we talk of, but ultimately it is the connectivity which still has some issues, and IIPM is situated in Orissa, a remote part of the Orissa. So today we had faced the connectivity challenge, but don't worry, we will record the session and we will share it with you all. So today we had planned thermography and wear debris analysis. So both the topics will be covered, and you will be getting documents also. You will be getting case studies also. So don't worry on that. So it will be a complete learning for all of you. So it was a great learning for 3 days for all of us. And we have learned a lot of things about condition-based monitoring system, about wear debris analysis, a brief of it. We have understood about thermography. We also heard the practitioner views and understood a lot of practical case studies through which we understood how industry people are using technology, how sensors are being used for production facilities. So first of all, I would like to thank IIPM for this wonderful theory session. Thanks to Professor Rajendra Kumar Barik ji and Viswajit Mohanta ji for this wonderful session. We could not hear you all today, we will record your session and we will understand all those things. Thanks to Infinity Uptime for showing the real life use cases and solutions and patiently answering the questions. Thanks Dr. Ronak and Putta for the same. Thanks to Pro MFG Media to pitch in today's session. Thanks Sai and Amita for the same. Thanks to NASSCOM COE and Amit Saluja for this association. Together we will have many such association in future, and we will have many such sessions. So thanks for guiding us on this session. From CIOs of India, I would like to thank all the participants who patiently came for 3 days and tried to learn as much as they could. But we will continue continue this kind of learning. And not only this session, as I shared yesterday, we are doing another session on 11th. Just a minute. On 11th, where you would be getting some of the lucky winners would be getting this book from Paul Dupieux. This is a leadership session starting at 12 p.m. and finishing at 1:30. So please join in for this session. And also we would be having our second Bala Memorial Lecture on 22nd of November. Last year for this session we called Professor Dr. Shekhar Pathak, and this is an initiative where we are talking not about technology, we are talking about the environment, we are talking about those concerns which are really important for all of us as a society and world at large. So we would be having a second Bala Memorial Lecture on 22nd November. It will be starting at 10:45 a.m. and we would be calling Padma Shri Ms. Sunita Narayan for the same. So please join in. We will share the link of registration for the same. So with that, I would like to thank all the EC members of CIOs of India who had helped us. Thanks to Atul for moderating the session. Thanks to Annie for bringing all the threads together and help us for conducting the session. And thanks to all of you for this wonderful 3 days together. Thank you.
I think you Kamal, you wanted to speak about the recording of these sessions.
Yeah, so we will be sharing the recording. Just wait. In the time Atul concludes, I will share the 2 recording in the chat box for last 2 sessions, and third session we will be sharing in the mail, and also we would be recording the sessions and we will be sharing the same with all of you.
Hello.
Atul, you are in mute. Yeah. Atul, you are on mute.
Professor Barik wants to say something.
Yeah, I want to say something. So what is the plan for next or today?
Barik ji, आपका क्योंकि आवाज we were unable to hear you clearly. There was a lot of breakage. आपका discontinuity हो रहा था उधर से, so we could not continue. But what is suggested is that no, we can have a separately. Myself and Kamal will connect with you. We will have a small recorded session which we will create, and not today. We will seek time with you. We will have a recording on the thermography का जो आपका aspects हैं और wear debris analysis का जो topics हैं. We will cover it in maybe 20-25 minutes. In that, and that recording we will share it with the participants subsequently.
So later we'll discuss it. Okay, so please conclude.
Yeah. Kamal ji, you were saying something.
Yeah, so I have shared 2 links in the chat box. These are the links for last 2 sessions. These are the sessions which are not made public. So these are only for the participants as of now. Once we collect all the data from you and we share the certificate with all of you, then we'll make it public also. So note down these 2 links and you can watch last 2 sessions. And today's session is also is being recorded and it will be shared in your email ID. Thank you.
Great. Thank you. Thank you, Annie. Annie, your video is off, it seems. Maybe I'm not too sure. Yeah. I think good. Thanks. And Annie, anything you want to say or we conclude now? You're on mute, Annie.
You are on mute, Annie.
Thank you. Thank you so much. I think we have exceeded our time, so we should conclude. And it was great learning. Hopefully, once we get the recording also, the learning will be complete. Thank you.
Okay.
Thank you. Thanks.
And
Thanks.
as usual, thanks for your great direction and leadership in creating and visualizing such initiatives. Between you and Atul, you're keeping us all engaged continuously.
Thank you.
Thank you.
Thank you.
Thanks much. Thanks.